Hello and welcome. This is lecture 17, part one. So, as part of this shift into physical design, we're actually going to take a pause on that. We're talking about open source project development, right? In other words, what does it mean to develop a project and what does it mean to consider open source? So both those things together. So, take a minute to pause and think about what would be the ideal code. Perhaps you have a certain thing in mind and you're searching the web to see if this exists, right? What would that look like? Closing your eyes, dreaming. Um, Number one is correct, right? You're hoping the code you get does the right thing, right? Uh, and let's say hypothetically for this application you're looking for, maybe there's situations where the inputs there isn't a right answer. Fine. You want the tool to tell you that, hey, these are incompatible inputs, assertion fails, or even tells you an error, hey, this is not okay. Um, because we want this code to be correct, and correctness isn't just that it actually is correct, but somehow you are convinced it's correct, right? So perhaps, it's produced by a credible organization. Perhaps you have a lot of tests you can run. You can see a test passing. Okay. Additionally, what else makes a code nice to work with? It's easy to work with, right? It's documented. Rather than being this giant mass of code, you actually understand what's going on there, right? It's easy to read and modify. Additionally, what else do you want? You want to be efficient. And by efficient today, we're being very hand wavy. We're saying not much room to improve, right? It's pretty good shape. Um, and so if you think about all these traits and you think back at the code you've written, let's say perhaps in your course projects for other courses, you'll realize you probably didn't reach all these metrics fully, right? And that's not anything wrong with you, that's everybody, right? It turns out if you go find high quality open source code, it may have many or all of these traits, and that did not happen on the first draft, right? It doesn't just happen instantly, right? Someone doesn't just sit down and type it all out. I know large language models make it seem like you just type code like that, right? But that's usually not how it happens. For those of you who are huge LLM proponents, you may notice that some of the more recent advancements have been these reasoning models that run the LLM repeatedly, right? In other words, this revising and iterating approach is not just good for humans, it's good for AI agents as well. Um, that's what I'm pitching, right? We want to revise and improve, right? So talking about all quarter, we've heard this agile process, get started, revise, and improve. And so today's talk is well split over across the next lecture. We're talking about what are these things we can do to improve, what are we using tools, personal processes, or processes of other humans to try and get this code to that place we want to be. Cool. So how are we going to do that? Well, talking about a lot of nitty gritty things that actually exist. For example, continuous integration, a way to keep running tests. Code management, how do you keep track of all this code for this big project? Documentation, and finally, the namesake for this whole lecture, open sourcing it. So first off is continuous integration. So what does that mean? That means we want to keep running tests, right? So if you have a big project, not just working by yourself, many people, even by yourself, as you keep writing stuff, despite best efforts, bugs will find a way into your code, right? And so when bugs find their way in, we want to identify them as soon as we can. The sooner we find them, the easier it is to fix. Um, There's one thing is a bug's been lying there dormant for 15 years. It's another thing if the bug was introduced last week and you find it next week and you remember, oh wait, so-and-so changed this code for this reason. So-and-so's still around. You can go talk to them. They can figure out what they changed, why, and then make the bug fixed, right? And so you want to find bugs as soon as they happen, ideally. And you want to be aware of that, right? It's often can be caused by integrating things. That's where the name comes from. But sometimes it happens even in isolation, right? And so what do you want to do? Well, course theme, right? Make tools do the work. If I'm typing on a computer to write code, that computer is not doing work otherwise, right? It's not very much demand. How to run tests, right? Have servers in the cloud run tests, right? If you have these tests, just keep running. Every time you change the code, run the tests, see if anything is happening. So I'll show you in a second how it's set up to check every commit or every pull request. It can run those tests for you automatically. Once again, use the humans keep going about. Until you don't run tests at all manually, if you run tests manually, you're kind of developing and testing things. At some point, you know what, this is good. And however that code finds its way upstream, keep running these tests, see what's happening, right? And so this is one of the things where I keep saying, testing isn't just about testing once you're developing it. It can be used so many different times, right? So having this continuous integration to CI and making it publicly visible lets other people know that you are testing. That increases their confidence when they test out your code. It also, for example, if someone does something like submitting a pull request by seeing the CI, having the CI run on it, you can see before you even spend time reviewing this pull request to make sure it didn't break all of your code, right? So now the pull request and the CI is all red, saying this thing breaks all the code. You're going to say you should fix that first before you bother wasting time reviewing it, right? And so this is really, really helpful for checking, external contributions, internal contributions. Um, let's say you are trying to do well and you're trying to modify someone else's project, and you're not sure if you're breaking it or not. Test and see how you kind of see that. So um, maybe I'll take a pause for a second. So if we go to Sales3 on GitHub, uh, let's see a CI for our beloved language. Um, so the few ways to get there. One way is to go to city actions, right? So yeah, you can see that there's all this stuff going on, and you can see that there's so many times how recently all these tests have been run, right? Um, and so there's various reasons why it's been going on. Some of them are pinned. You can see people have been uh, having them run in response to certain pull requests. This is all running, right? So each time this is happening, it's running. And, oh wait, someone submitted a patch on how to change the Java table. It failed. Someone, so guess what? They fixed it and submitted it again, right? So now if you're coming in to review this, that's a much better sign, right? Um, and you can see there's various steps, right? Make tools do the work. This is not human work. You set the continuous integration up, and then you go about your life, and you come on and check it back in this to see how it's happening, right? And so what do we need to get this going? Uh, we need a few things. Number one, you need tests. I've been pitching tests from the beginning, right? You don't write tests at the end with a little detail. You write tests during development. You write tests before you start development. They're really helpful, and CI gets you more value out of those tests, right? You might share, are these tests worth it? CI gets you more value. Do it, write the test. Um, some people may push back on my testing enthusiasm and saying, oh, well, I could write something that would pass tests but be buggy. And it's like, that's totally true. Sounds like your tests are complete, right? Make better tests. Increase your test coverage, right? If something can be pass the test and be buggy, it sounds like you need more tests, right? Um, or maybe you need to change testing methodology or something. So number one, you need tests. Then you need some way to kind of script things and automate things. Don't need to invent the wheel here. A lot of things already exist for this. Um, and so definitely take whatever you can. And in terms of running it, you can run it locally. Maybe your organization is worried about running things in the cloud, so you run in a local server for this, sure. But a lot of things are available in the cloud and they're easy or free. For example, GitHub Actions are, depending on your GitHub account, free. Really easy to set up. Just a second ago, we were looking at all these things here. These are GitHub Actions here for Chisel. And so that's what they're running. Yeah, and you can see, right? So how do you set up that kind of stuff? Well, if we go back to the code base, oops, and then we go digging in here. So now remember, GitHub's a massive, project, right? We got 147 contributors. So this isn't quite the same for your project, but yeah, you can see, depending on what workflow you're running, usually have one of these .yml files, the YAML file. This one's really long. You can probably set within like 20 lines for this course. So basically, you kind of describe, what it is, the VM to run it on, any details, and then you have steps for what you actually want to do, right? In this case, there, for some reason, echoing process in there, but sure. I don't know quite what's going on, but you can see what's going on. In this case, you're doing a few things. And so um, setting up the continuous integration might be a few hours in the afternoon, but once it's running, it's really useful. There's lots of there to help you out with that, right? So like I said, GitHub Actions makes this a lot really easy. Following something called Jenkins is really popular, etc. Cool. Um, so what kind of tests can you have inside your CI? All sorts of tests. And you may hear these terms kind of tossed around. People have slightly different meanings when I say them, but let's kind of cover them. So number one, unit tests, right? Testing module component isolation. This is the key building block. And you've seen that already in this entire course, right? Most times when I show you choose a component in lecture, usually there's a test to show that module isolation, right? And so unit tests are a starting point. Then you have integration tests, combine multiple tests together, or multiple components, and we'll have your tests kind of capture all these. So it can be multiple modules working together, it can be the entire system working together, sure. Those are kind of the baseline types. Unit tests versus integration tests, sure. Then there's called regression tests, which are tests that are checking things you don't check as often. Maybe things like trying your code on older versions of the tool, maybe really, really exhaustive tests that check really, really esoteric things, but you still want to regression tests to make sure that your code is not breaking. So these are things you expect to work, but if for some reason these stop working, you want to know right away. You may hear the term smoke tests. These are tests that are really short and fast running. And so basically, yeah, you can definitely pass a smoke test and be buggy. But if the smoke tests fail, you know you're in trouble, right? You know this thing is really not working right now. Um, Additionally, you may have performance tests, which for software performance testing is actually a little bit tricky because you have a kind of a quiet machine to do the measurements. For hardware, it's easier, right? You can push this through your flow and be like, oh, wait, all of a sudden our design had a certain clock period, and now we're 20% slower. Whoa. We want to know that, right? And so that may not be obvious because, here you are writing RTL code, and, you pushed it, and your teammate approved that it got merged into the code base. And then guess what? That nightly continuous integration run ran and then detected, oh, wait, our clock period got 20% worse. We got to go fix this. And you want to know that right away, right? Rather than finding out weeks or months later. Um, like I said, so make tools do the work, right? Have servers running, rather humans debugging, right? It's kind of the idea, right? And turns out with CI, much of the time, most of the time, all these tests are going to pass. Great. The few times they fail, that's really valuable. 'Cause that means you found something, right? And you want to act on that. Because otherwise, you spend a lot of time as a human debugging it. And the later these bugs get found, the more human time it is to fix, right? If you have a regression in your critical path and you don't find it until like 2 months later, that's a big problem, right? You'd rather know about that right away, change architecture if you need to, and that kind of stuff. You want to know this early, right? It's not about correctness, it's also about performance. And so have tools doing the work, keep running, keep checking stuff. And realize when you have this kind of automation to make CI run, you can choose which tests to run under which cases, right? Maybe for every commit, you have to do a smoke test to make sure that doesn't break the build, so to speak. But then you do your biggest regression test maybe only once a night or something, or your performance test only once a week or something, right? But you can kind of turn these knobs. Cool. Any questions on continuous integration CI? So next, let's talk about code management. So um, in this course, we've used Git and not even talked about Git. So I'm sure you all are appreciative of Git or things like it. Um, Obviously, using version control is really, really important. You'd be surprised to find how many hardware companies don't fully embrace all of the Git style things if they aren't using Git. Um, and so, yeah, it's good to have version control and using not just to hold the code, but actually to like collaborate well, track changes, document changes is really, really important, right? It's one thing to have, your entire code checked in the Git and say, oh yeah, my code checked in the Git and have like 2 commits for your entire project, right? First version, second version, boom, done, 2 commits. I like doing a lot of Git commits, right? Every time I make a significant change, label that, and someone else can go through history later on. They can see scrolling through what changes are required for this thing. It makes it much more intelligible, right? If you find yourself unsure of what to say in a Git commit message, that's probably a sign your commit's too big, right? It's like if you can't describe concisely what it's supposed to be doing, because it changes like 10 things at once. If those 10 things aren't somehow related, probably shouldn't be one commit. Um, so that being said, how about some opinionated advice on how to use Git in practice? Um, there's some features that are Git that are really helpful, and they can be great if used well, or it can be a disaster if used not greatly. So things like a submodule. Submodule allows you to put a Git repo, a reference to a certain repo and a certain commit into your repo. So why is that helpful? Well, imagine for this project, some people have asked me, oh, well, there's already this existing code. Can I use that? And it's like, yes. Yes, you can. You can build on top of that. And so wouldn't it be great if your code management tracked that dependence on which version you want? Yes, that's what submodule is for, right? You can definitely say, hey, I want to include this repo with this commit. Great thing for submodule. Um, However, let's say you yourself are building a big project and you are kind of deciding, wait, I have a big project, a lot of things going on. Should I have multiple directories in one repo or make multiple repos and have a bunch of submodules and stuff? Um, I would push back on getting too gung ho on submodules of things you can control. For things you don't control, they need to be submodules. But things you can control, there's kind of philosophy of having more things in the same repo. So if you take it to an extreme, it's called a mono repo, of course. But um, only have separate repos that really are separate use cases and it can be used independently. But yeah, it's really good for tracking things. Cool. What else is there? Branches, right? We've all seen branches in Git. Um, I recommend very few long-lived branches. Otherwise, it's really painful to maintain. I also remember many years ago getting really excited about branches and having like 400 branches in the same project. I also recommend against that. So don't be afraid to use different files and folders, etc. But branches are great for if they're short-lived, right? You maybe make a branch to do a pull request, and then once it gets merged, you can delete it, um, etc. So I said that term, pull request. What is that? That's a way with Git, or I guess I should say GitHub specifically, to kind of track things. In other words, there's a repo, you point to another branch and say, hey, I want this to be merged into that repo. And it gives someone a very clear proposition. Okay, here's the code someone wants to have there. It's much more controlled, right? The alternative to a pull request is someone just having write access to your repo and they can push commits there. And if they're doing good work, perhaps it's okay, but maybe not. And so pull request makes a lot more structure. It gives you a chance to do reviews. Also to do multiple commits. Let's say you have one person A doing task A, person B doing task B. Each of them does 5 commits. And then they're kind of pushing to the repo at the same time. The code is kind of changing, this knee-jerk way back and forth. As opposed to pull request A, pull request B, you can see those 5 commits to do all the things for each of those tasks. You agree to them, and they kind of come together all at once, right? And so, yeah, even for a project pair, you may consider having people work. You're kind of in that sweet spot where if you really want to trust each other and talk to each other a lot, you can both push to main. That can work. Or I recommend maybe trying out some pull requests. And you do a pull request, and you have all the things you're adding into the project, then you can merge them in bulk. Cool. So what about code reviews? So remember at the beginning of the lecture, I was saying how, we always had deals for what we want so nice code to be. And I mentioned this like certain amount of polish is hard to get on the first draft. One thing we could do to improve that code quality is a code review, right? Another one we talked about just a second ago, which is of course continuous integration, keep testing, trying to find those bugs. But what's a code review? Code review is a way where you can get feedback on your code. And if you think about it, much of the code you've probably written, or maybe all the code you've written, is basically rough draft, right? Once you had it working and passing tests, once you submit to this course's auto grader and you got 100 points, you're probably like, oh, great, done, and moved on, right? And the question is, can you go back to that code and say, how can I make this better? Maybe even rewrite it if need be, right? And so the code review is a way where you get someone else to look at your code and give you structured feedback, try and make it better. Um, and so think about like writing, right? Like if I'm trying to write something, whether it be maybe a journal article, like a paper for a academic publication, or maybe like a article for like a periodical, like a news source, you probably can't just write it start to finish correct from day one, right? We know you can't, right? You're going to write a rough draft, you're going to revise it, you're going to revise it, you're going to rewrote this portion, write that portion, rearrange it, right? Same's true for code, right? Um, when you get it working the first time, great. That's a rough draft. Then you got to go in there and, you know, improve clarity however you can, right? And so usually for code, we're so focused on functionality, but trust me, thinking about readability and clarity really helps. If you can make your code simpler and easier to read and often shorter, months, years later, you come back working in that code, it makes life a lot easier, right? And so this code review is a way to kind of get that feedback, right? Because you're trying to write a human readable article like in English or something. Like I said, you're probably going to do the best you can on your own and you can show it to other people, hey, give me feedback, give me feedback, give me feedback. That's a code review. Give me feedback, right? Um, so all sorts of ways of doing code reviews. You're going to do code reviews in this course. You're going to do two. You're going to do one where you're going to review someone else's code work 5. And then the second one's going to be review someone else's project. It's a chance to kind of get used to this experience. And you'll see that like sometimes, they aren't as helpful as you would like. They kind of see things you kind of would know. Like, yeah, I should have done that on my own anyways. Other times, they make sure it's something new and it's helpful. You kind of get that little bit of help. For those of you that are becoming very attached to having your AI coding assistants, in a way, it's kind of a code review, right? The AI is looking at your code and telling you, hey, wait, could you have done this alternatively, right? And so uh, I think at least for a couple of years, code reviews by humans make sense. Maybe in 10 years, I don't know if AI is going to do it, but um, it's still helpful, right? To get that feedback, what would make this more clear? What considerations you should be aware of, right? And so it can be things just about readability. It can also be things about correctness, where like it passed tests as they're written, but maybe someone else can see an issue you didn't think of, right? Um, so reviewed code tends to be a lot better, or at least more consistent. If nothing else, it may say, this is the way we have our coding style in this organization. You need to be more like this, and that way it kind of makes things, more uniform. Also, the notion that your colleagues don't spend time reading it often makes you do a better job at writing your code. So by me telling you, for example, your homework five is gonna be code reviewed, maybe you're all gonna be worried, oh wait, I made my homework five look prettier. So maybe I kind of spoiled it a little bit. But yeah, it helps, right? Kind of that motivation. And also looking at code, talking about alternatives, reading other people's code and learning from what they're doing. These are all ways to kind of get better as a developer, right? So both improving your own code, seeing other people's code, getting feedback. Code reviews really help. It's one of these things that like is done as standard practice in the industry, and we don't really do it all teaching, right? And so that's why I have it a little taste of that in this course. Hopefully you're aware of that and you see some benefit to it when you finish this course. And then when you go off to a job, you'll not be surprised until you got to do a code review. Um, cool. So what happens in the code review? Typically, the person creating the code, has finished the code. They've done their best to polish it as best they can, but then they somehow initiate the review process, right? So maybe a common way of doing that is you perhaps open a pull request and also request someone to review the code, right? Um, okay. Sometimes even it's mandatory. Some projects say you can't merge a pull request into the code base until it's actually been approved, right? It actually has to have a code review in order to be merged. Um, so reviewer looks over your code, does a code review, um, and once again, making tools do the work. Some tools can help run, uh, makes it easier for them, right? For example, maybe run continuous integration runs. They see does this pass the test before they even look at it. Maybe you have a style checker, a linting tool, checking the code for formatting consistency before they even look at it, right? So by the time a human looks at it, they know at least it passed the test and perhaps it's properly formatted. Great. And they can start focusing on what they want to do. The software is part of the code review process, makes it easier to kind of annotate where in the code you're talking about things. And then the perhaps, in very commonly, you're not going to prove the code the first time, right? You can get feedback. The submitter goes ahead and revises their code according to the requests. And then eventually, after multiple rounds of reviewing and revision, the reviewer says, you know what? LGTM looks good to me, thumbs up, and you get approved. And then once it's approved, then the code can be pulled in. So um, I had a pull request here, right? So this is the pull request in the Chisel repo I pulled out a year ago. So someone was doing it. So for example, you can see this very formulaic form. Uh, they have a form in this repo template to kind of guide people to do a pull request. So someone did a pull request, or as the title suggests, they're trying to report host locator when scoping messages, right? So you can see that this is a very detailed esoteric thing. This is pull request 3,804. So they've been doing this for a while. And so you can see there's kind of these checklists, making sure that they uh, satisfy certain criteria. For example, do you have a test that demonstrates functionality you're adding is actually there, right? Did you make sure to delete any bugging printfs, right? Um, are you telling people why we're doing this? Like, what is this actually there, right? How should this be merged? So all these kind of details are kind of living here, right? But then ultimately, this person requested a review by someone else. Now, if I actually look at the changes, right? So here are the changes that this pull request brought in. Great. Um, and then there's some conversation back and forth between the two of them, right? And eventually, after this, it was merged in. And you can see now, once again, making tools do the work. There's actually various other bots here that will go ahead and backport this to various other branches, etc. So yeah, this is, this in practice. Cool. So what kind of things you look at if you have to do a code review? Every organization has their own policies. You can kind of see from that thing you're just looking at, you can kind of see before it even got to the beginning, there's kind of making sure the contributor did their due diligence. And then the reviewer also there's some kind of bare minimum due diligence they got to do. Um, but a lot being checked for. So number one, correctness, right? Making sure this is not going to break stuff. Checking to make sure the added tests should be running new tests for this functionality, etc. Things like readability and code style sound trivial, but they really add up for a big project, right? Like the thing you don't want to have happen is in a big project, just have someone open up a file and without looking at the version history or looking at the comments, know who wrote this code. That's not what you want to have happen. You want to have this code as kind of nameless because it's all kind of very similar. That's make it easier for everybody to read. But if you have someone who has a very unique coding style and that's allowed to persist in the repo, that just increases the cognitive load of everyone else trying to read it later on. Um, so readability is extremely important. That's a big part of code reviews. And then, of course, completeness, making sure, they said they have tests, they have documentation, etc. Um, when you do code reviews for this course, I'm going to give you a suggested list of questions to make sure to check for. Cool. All right, let's just keep rolling then. Okay, so we've covered continuous integration. As making tools do the work, run a lot of tests. We've talked about how to manage your code, things like Git, things like pull requests, things like code review. Um, what else is helpful? Documentation, right? Explaining what is there. And little do we know, all documentation we've done for the last, few decades has been great fodder for LLMs, right? They're all now experts in our code because of documentation. Um, so what does documentation do, right? Um, it has multiple roles, and you appreciate different parts of the document do different things, right? Number one, summarize what the project does. Uh, that sounds like a really low bar. You'd be surprised how many projects fail to meet this bar. Going around on GitHub, you come find some repo and someone linked to it or something. You're like, great, and you get there. It has some sort of name, like this is the foobar project. Okay, great. You scroll down to the README. What does the foobar project does? And it's like the first sentence is, this is the repo for the foobar project. Great. It's like we depend on this compiler version. What does it freaking do? Like I don't even know what the foobar project is. Like what is this freaking like? No, summarize what it does is a really important task. Instructions how to use it, sure. Details the internal structure and functionality, yes, that's also important. Um, Here's the thing about documentation, right? The people who make code are the ones sometimes least concerned about it because they know what the code does, right? And so the person's most hurt by lacking documentation are the ones that are actually your users or contributors, right? In other words, if your team knows how it works, you guys don't care, but people on the outside trying to use it, they will care. And documentation can be the difference between something being adopted or not being adopted, or between somebody contributing externally to your project or not because they can't even get the foothold, right? So good documentation can really help. It can help get you users, help get you contributors. That's what you want to have your open source projects take off, right? And so in order to get documentation right, you got to think about a few things. So you got to think about somebody coming from the outside, how they can perceive this. Like I said, you're that person scrolling through on GitHub and you're trying to figure out what the foobar project is, right? Tell them what it is. Okay, we're doing a certain thing. Um, and thinking about its interfaces and features in that sort of way. Cool. Okay. So how can you document? All sorts of ways to document, but really kind of think of it as three different levels of documentation that are possible. Number one is the README. Like I said, it's the bare minimum. Not only does it live inside your code repo, but on sites like GitHub, that's also rendered. And so that's really easy to see, right? I mean, if we go back, we were just at the chisel, repo. We've seen chisel documentations all throughout this course, but there's also the chisel README, right? And it tells you right away. It's a open source hardware description language, right? It tells you that right away. It doesn't say this is the chisel project and then not tell you what it does. It tells you what it does in the very first sentence. That is good. Do that, right? And this README, of course, doesn't cover everything. It covers a good amount of stuff, right? Um, and it links to a lot of other documentation, which is great. Do that. Um, so number one is the README, right? And for this course, that's probably what you're gonna do for documentation, right? Cool. Make a nice README, use Markdown to make it formatted. Cool. Number two is actual code documentation. So you've seen this before. Look at the chisel features, right? A Scala doc or a chisel doc, right? Um, it's really nice, right? You can write the documentation in the same file as the code. So that way, they're easy to keep synchronized and together. Some very smart IDEs actually recognize the comments for Scala doc and render them as pre-documentation in line. That's pretty cool. Um, of course, you can use another code tool to actually have it get rendered, and we've seen that all quarter. So I believe if I um, what quarter we had the same docs open, I will sheet by going to the course homepage. But yeah, so if we go to like the API documentation, right? So this is generated by Scala doc, right? And so yeah, I mean this is helpful, right? And so someone inside these pieces of code um, had to stare side by side. So go to like the vec, right? There's documentation here. Go look at the vec code. Oops, scroll back. Trying to find the Scala doc. Maybe vec's not the best example. Let's go find. I'm gonna go to util. which is okay. Yeah, fine. Let's go find some electrical components we recognize in util. How about something like an arbiter? So here we see some documentation on some of the fields. Go read arbiter.scala, and you can see some of the Scala doc stuff associated with it. Cool. Um, but that's not all. There's another kind of documentation, which is just a static web page, right? Which people also can do, right? And there's a lot of ways to write these. There's a site, Read the Docs, which makes some really pretty helpful ways of hosting it. Um, the course web page for this course, which I've now lost the thing for, this actually is a static site generator designed to write documentation, right? You can see down here, uh, tech doc, right? So uh, documentation in this course is the case is the course material. Um, yeah, so these are all sorts of ways you can document your project. It's really worth doing. It's not just a nagging detail. It makes it all the difference in terms of this getting adopted or not. Um, okay, so more opinionated opinions. Okay, so when it comes to writing documentation, as I said, number one, please, 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 please include a summary of what it does. I said, you're surprised my projects fail this test. And I'm not going to name names during lecture, but you will come across this going around GitHub. It's actually really polished README. It's like, 500 words, a lot of stuff in there. Sometimes I forget to mention the most important thing is what the thing actually does. Um, so don't forget to include the brief summary of overall function and purpose. Um, emphasize the purpose of things, right? It's really easy to program, especially if you've written something, to think about, oh, how does it work? That makes for really confusing reading. Describe what it's for, what it does from the outside. And if you've designed it correctly, people shouldn't need to know what is inside, right? All they should need to know is what it does on the outside and that it works, right? They shouldn't care about the inside, right? So emphasize the purpose over implementation, emphasize the, interactions with this thing over the details on the side of it, right? But a lot of times someone has documentation, it's like, oh yeah, first I introduce this concept, then I want to introduce this concept, and you understand what this kind of object is, and it's like, I don't want to know what all these things are. I just want to know how to use this thing, right? Take those abstractions and get that right. And you may find that writing documentation, you may find something that's really hard to explain. That may be a suggestion, not just hard, you're not good at writing documentation, may actually be a sign that the way you structured your project and the way you structured your abstractions um, is confusing. You make sure you reconsider that. Cool. I think that's a great place to stop. Any last questions? Okay.